Okay, so we are moving into chapter 11 today, which is rational expressions and equations. Hopefully with what I am doing, it's going to help ease this over. So I'm going to try and give you guys a video from me for each of these. So a rational expression is just simply a fraction whose denominator or numerator both have polynomials in them, which means they have a variable. So an x, a y, a z, sometimes both, x and y. Now, a couple of these things we need to remember are the basic rules of fraction arithmetic. Now, I'm on page 406, so pay attention to these. We need to remember how to reduce to lowest terms, so by taking out the greatest common factor. We need to remember how to multiply, straight across the top, straight across the bottom, reduce to lowest terms. We also need to remember how to divide. This is keep, change, flip. So keep the first, change the symbol from division to multiplication, and flip the second fraction. Sometimes you may need to make, like what they did here, you may need to make that number a fraction. So they took a +3 and put it as +3/1 so they could flip it to 1/3. Don't panic if you have to do that. Just do it, okay? I still do it, no big deal, okay? Adding and subtracting, make sure they have the same denominators. So this is where they have to have the least common denominator. They have to have the same denominators to add or subtract. So I'm going to take these basic rules and I'm going to apply them to these rational expressions, okay? But before we can apply them, we need to make sure that we remember how to evaluate. So that's where example A comes in. So example A is going to give us the equation -3x over x plus 9. And it wants us to evaluate when x equals -2 and when x equals 3. When you have that and here, that means you're going to have two different answers, okay? So I'm going to do the first one first. So -3 times -2 over -2 plus 9. And that's going to give me -3 times -2 is a +6. -2 plus 9 is a 7 because it's 9 minus 2, okay? That is our first answer. Now remember, we have an and here, so I also have to do it when I have x as +3. So I've got -3 times +3 over +3 plus 9. -3 times +3 is a -9, and then 3 plus 9 is 9, 10, 11, 12. Now, I didn't mention it in the first one because I know 6 over 7 can't be reduced, but 9 over 12 can be. So I'm going to divide top and bottom by 3. And I'm going to end up with -3 over 4. Okay? That's how you evaluate. So evaluate just simply means plug it in. So if it says evaluate when x equals whatever, it is. Now, before we can continue evaluating, we need to know something known as undefined. So if you have 0 over 3, that's going to equal 0. Plain and simple. 0 divided by anything is 0. However, if I have a 3 over 0, that's going to be something known as undefined. So if I end up with the bottom equaling a 0, I don't even care what the top is. If the bottom is 0 in any way, shape, or form, the answer is undefined. So one of the quick ways you can do these problems is you can start by doing the bottom first so that you can see, is it undefined? And then save yourself possibly some extra work. So if you can't guess, we're going to evaluate another expression. So this is going to be example B. And it wants us to evaluate -2x over x plus 3 when x equals -3. Now, you guys know how Abeka works. It just gave us this big deal right here, which means this one's going to be undefined. So let me show you how we do that. We still set it up, -2 times -3, and we're going to put -3 plus 3 on the bottom. I'm going to go ahead and do the bottom first. I'm going to say -3 plus 3 is 0. Therefore, it doesn't matter what the top is. That right there tells me that it's undefined as my answer. So a little shortcut I just gave you for some of your work this afternoon. Now, we have to also determine the variable which a rational expression is undefined. So for this, the next thing I'm going to show you to do for example C and D is I'm going to show you how we tell, these are called the zeros for it. So it's basically what x cannot equal, because when we're solving these problems, and the whole point of rational expressions in this chapter is to teach you how to solve these. And so we want to be able to. However, the first thing we're going to do is say, well, it can't be these numbers. So for example C and example D, we are going to find a quick way to figure out what it can't be, okay? So this one tells us 2x plus 1 over 3x minus 5. It wants to know when x would equal 0. So what can it not be? What can x not be? What would make this undefined? I'm simply going to take the bottom of this expression, 3x minus 5, and I'm going to set it equal to 0. I'm going to solve for x, and that's my answer. Add my 5 to both sides, and I end up with 3x equals 5, divide by my 3, divide by my 3, and I have x equals 5 over 3. I can simply put a slash through that and say x cannot equal 5 over 3. Okay? Now, what this means is that if x equaled 5 over 3, my problem would then be undefined. And they don't want that. We're trying to solve these equations. And if we just sit here, it's like me telling you guys you can't give me, I don't know, as an answer. This is their way of saying you can't give me a, well, it doesn't work as an answer. They want a legitimate answer. So you have to decide, you have to tell them when it can't equal that. Okay? These are oftentimes called zeros in Algebra 2. So if you hear me call them zeros, I'm talking Algebra 2. I know you guys can get this stuff. Okay, so example D, I'm going to show you as well, but again, it's kind of doing the same thing. It just brings in some factoring, which I'm going to review factoring tomorrow as well. So you won't have any assignments tonight or today that deal with factoring, because I know that that is a sore spot for most of you. Okay, it wants to know when this equals 0. So I'm going to circle this here. I'm going to bring it over here, so x squared plus 5x plus 6. I have to factor this because otherwise it's not going to solve perfectly. So I can look at this and say, what two numbers that multiply together to equal 6 add together to equal 5? I know that's x plus 2 and x plus 3. When I set those equal to 0, I end up with x plus 2 equals 0 and x plus 3 equals 0. Subtract the 3, subtract the 2, x equals negative 2, x equals negative 3, and then I put my slashes through it, so x cannot equal negative 2 or negative 3. Now, that just simply means that if it is either of those numbers, the equation is going to end up being 0 or undefined. We don't want that to happen, so we don't want denominators to equal 0. So when you're evaluating, if the bottom ends up being 0, it's undefined. Otherwise, solve the equation and reduce to lowest terms. If it asks for when the equation cannot, what x cannot equal, you're setting only the bottom to 0. You don't have to worry about the top, because if the top comes up to 0, the answer is just 0, okay? But if the bottom comes up to 0, it's undefined. So that changes the entire way these problems work. Okay, good luck. Let me know if you guys have any questions, and tomorrow we are reviewing factoring, so don't panic about example D. We're going to go over it again.